This is 5.5, day 1, part 2, using the double angle formulas. I do have them in the box here so we can refer to them. So now we want to take this red equation and find out the exact solutions to this equation. And we only want it for the first revolution of the unit circle. So what we have in this first question is a double angle. We have the sine of 2x. So if I come over to here in this box, I can replace that double angle with 2 sine of x times the cosine of x. And then that cosine of x is still the same. So this piece here, sine of 2x, replaces with the double angle 2 sine of x cosine of x. Now we want to think back to earlier in our chapter 5.3, and we want to find out what are the ways that we can find out what x can be, what angles. So we want to use factoring. Is there a GCF in this question? Yes, we can take out a cosine of x from this equation. So we're going to factor out the cosine of x. And so now what we're left with is the 2 sine of x. And then taking out a cosine of x from this piece gives us just the 1. Now we have it factored out, so we set each factor equal to 0 and solve for x. So we say the cosine of x equals 0, and 2 sine of x plus 1 equals 0. Now we solve them separately for x. So in this first question, the cosine of x equals 0. Where on the unit circle does the cosine of x equal 0? So again, we want to have those in unit circle. So the cosine of x is pi over 2 and 3 pi over 2. And then the second equation, we have to undo the 1. So we're going to subtract 1 from both sides. And then we're going to divide by 2. And then we want to find out where in the unit circle for the first revolution does the sine of x equal negative 1/2. Well, that is 7 pi over 6 and 11 pi over 6. So those are our 4 solutions to this equation. You can substitute them back into the original question and solve for x. Here's another similar question where we have a cosine of 2x. So this is our double angle. Now we have 3 choices. We could replace it with this first one, the second one, or the third one. I'm going to substitute it with the third one. The reason why is I already have a sine of x right here. So I'm going to convert everything to the same trig function. So I'm going to replace this cosine of 2x with 1 minus 2 sine squared of x. And then I have that plus sine of x on the end. Now I'm going to put this in standard form. So it's negative 2 sine squared of x plus the sine of x plus 1. Now I have a sine squared of x, so that tells me I want to factor it. I could either use u substitution or just factor it as leaving the trig function in there. So I'm going to divide everything by negative 1. So this becomes now a positive 2 sine squared of x. This now becomes a negative sine of x. This now becomes a negative 1. So I just changed the signs, everything, to make that leading coefficient a 2. Now you would use either AC method or guess and check. So I'm going to split up that 2 sine squared of x into 2 sine of x and then sine of x. Then remember, I want this negative 1 either to be, when I split that up in factoring, is either negative 1 times positive 1. So you have a couple different options to split up that 1. Now I have it factored, so I'm going to set each factor equal to 0 and solve for x. So 2 sine of x plus 1 equals 0, and the sine of x minus 1 equals 0. Now I solve those for x by undoing. So 2 sine of x, subtract 1, and then divide by 2. Then over here, add 1. And now we use our unit circle. And we say, when does these angles equal negative 1/2 and 1? So we use inverse trig. So where on the unit circle does the sine of x equal negative 1/2? Well, that is 7 pi over 6 and 11 pi over 6. Then again, in the first revolution, when does the sine of x equal 1? Well, that is at pi over 2. So here are our 3 solutions to this question. Here's our last problem. We give you that the cosine of u equals negative 2/3. So now we're going away from the unit circle, and we want the angle to fall in the second quadrant. The angle is going to be between pi over 2 and pi. And we want to find the exact angle of the sine of 2u, the cosine of 2u, and the tangent of 2u. So let's go ahead and draw a picture of what we're given. Remember, the cosine is found by taking x over r. So we want to draw a picture. Here is pi over 2, here is pi, and we have circular trig. So we're going to construct a right triangle. Here would be our radius, and then we're going to drop down that triangle, the right triangle. This is the distance for x, and then this is the distance for y. Well, from our given trig function, we know that x is negative 2, and that r is 3. There's one piece we don't know in this right triangle, is the y. So we're going to use Pythagorean theorem to find that y value. So we say negative 2 squared plus y squared equals r squared. And now we solve it for y. So we square those terms. Then we undo the 4. And we get y to be plus or minus the square root of 5. So now, if we look at the second quadrant, it has to be a positive y. So there are 3 values. Now, before I go and begin finding the double angles, I just want to find them as sine of u and tangent of u. So we already have this one given. The cosine of u was negative 2 over 3. Remember, the sine of u is taking y over r. So square root of 5 over r, 3. Then the tangent of u is y over x. So square root of 5 over x, which is negative 2. Now we're going to use these 3 values to find the double angles. So the first one is find the double angle, the sine of 2u. So we have to use this formula right here. It says 2 sine of u, cosine of u. Now you substitute in your trig function. 2, the sine of u is 5/3, or square root of 5/3. And then the cosine of u is negative 2/3. And now we simplify these 3 fractions. I'm just going to throw a 1 underneath that 2. So we multiply across. 2 times negative 2 is negative 4. Square roots of 5 over 1 times 3 times 3, which is 9. Now, cosine of 2u, we have 3 choices to use. I'm just going to choose this one here. 2 cosine squared of u minus 1. Well, 2 cosine of u is negative 2/3. So we're going to square that and then do some simplifying. So negative 2/3 times negative 2/3 is 4/9, and then minus 1. Should be minus 1 here. And then multiply across. 2 times 4 is 8/9, and then minus 1. And then I'm going to just change that 1 to a 9/9. So we're left with negative 1/9 is the value of cosine of 2u. And our last one, the tangent of 2u, we're going to use this formula. 2 tangent of u minus 1 all over 1 minus tangent squared of u. Remember, the tangent of u we found to be negative square root of 5/2. So again, the tangent of u is negative square root of 5/2. And now we substitute it in for the tangent. So 2 times negative square root of 5/2 minus 1 all over 1 minus negative square root of 5/2 squared. Now we start simplifying. So we could distribute that 2 through. These 2's will cancel. And then in the denominator, negative square root of 5 times negative square root of 5 is 5. And then 2 times 2 is 4. And then we have in the numerator negative square root of 5 minus 2 over, I'm going to change that 1 to a 4/4. Keep the numerator. And then 4/4 minus 5/4 is negative 1/4. I'm going to let you continue simplifying that. We do have a fraction over a fraction, and I think you're probably comfortable with the rest. The lesson homework for 5.5 day 1 is page 394, 1 through 8, 9 through 15 on, 19 through 22, 23 through 27 on. Good luck.